Alright, here we have the 2.2 guided notes. Again, the vocabulary you're responsible for is written there for you. But again, a lot of this is going to be discussed in the notes in the video itself. A linear equation has no operations other than addition, subtraction, and multiplication of a variable by a constant. A constant is just a number. That's it. It's a number. Now, a linear function has ordered pairs that satisfy a linear equation. Okay, so what does all this really mean? So we want to be able to determine whether a linear equation is or whether an equation is linear or not. Excuse me. Whew. So what we really want to determine by all this information is whether or not an equation is linear. So let's see. Let's try and determine if the following equations are linear. So we have, for this one, I have 7 times x. So I have a constant times a variable plus a number, so that's okay, equals another variable. Well, sure. So this one here is linear. So I'm going to say yes. Yes, you're linear. Now I have a variable times a variable. Can I do a variable times a variable? Up here it says a variable by a constant. Multiplication of a variable by a constant. Well, this is a variable by a variable, so this is not a linear equation, excuse me. Here I have a function, and here I have f of x equals x squared plus 7. So the x squared is really saying x. Whoa, let's get that right. X squared is really saying x times x. And just like we saw here, a variable times a variable, well, a variable times itself would not be linear, so this is a big no. Square root of a variable. Can I square root a variable? Is that one of the things I can do? Let's check. Operations of addition, subtraction, and multiplication of a variable by a constant. A variable by a constant. That's a square root. That's neither addition or subtraction, so this is a big resounding no. X minus y plus z equals 20. I have 3 variables here. Does that mean I can, is it still linear even though I have 3 variables? Is it a line? Well, it's doing nothing with x, is doing nothing but subtraction of y, so, or x minus y. I can do that. That's okay. That's part of the rules. Y plus z, again, those are part of the rules. I can do all these things. So this, yes, is indeed a linear equation. Now here I have division, so can it, is this a function, is this not a function, excuse me, is this linear? Even though I have division, what this is really saying is 1/3 times x minus 7/3. 1/3, that's a number, and it's being multiplied by my variable, so yes, indeed, this is a line. Okay. So how do we normally see lines in mathematics? Well, we have different forms of linear equations, and the standard form of a linear equation is anything in the form of ax plus by equals c. Okay, so let's do something here. Let's just make sure, though. So the standard form of an equation, all of this business, all I'm really worried about here is that a, b, and c are integers. In other words, no fractions or decimals. Okay. And I want a to be positive. A must be positive. Okay. So let's just ignore all the fancy math here, and I'm going to do this. Alright, so standard form, I want no fractions or decimals, and a must be positive. The value of a a, this a right here, must be positive. So let's try that out. Y equals negative 6x plus 5. I want to get this in standard form. And again, standard form is anything in the form of a, x plus b, y equals c. All right, so my x is on the left-hand side along with y. So let's go ahead and move negative 6x to the left-hand side by adding 6x to both sides. So now I'm going to get 6x plus y equals 5. Now 6, 1, and 5 are all integers. So this is in standard form. Okay? Now I have 3x equals minus 2y minus 1. Excuse me, I'll read that again. 3x equals negative 2y minus 1. Again, I want my x and my y values on the left-hand side, so I'm going to add 2y plus 2y. So now to clean this up, let me separate that out. To clean this up, I get 3x plus 2y equals negative 1. Good. My a value being 3, a times x, 3 times x. So my a value of 3 is now positive, and I don't need to worry about the other two being positive just as long as they are integers, a number on a number line. So here we go. I got that. Now, let's do the last problem here. Y equals 4x minus 10. So again, I need to move the 4x to the other side, so I'm going to take 4x away from both sides. And now I have minus 4x plus y equals minus 10. Now in general I'd be done, but again, my a value must be positive, and right now it's negative. So I'm going to multiply everything by negative 1 times negative 1. I'm going to multiply this by negative 1. Essentially switching the signs of all three terms. So now I have 4x minus y equals 10. And that's really all we have to do for problems like that. Okay, so this is really a refresher and a review. But, excuse me, I want to talk about the x and y intercepts. So, the what is a point at which the graph crosses the y-axis? It's the y-intercept. And the x-intercept is the point at which the graph crosses the x-axis. Again, this is review for most of you, but that's the definition. X-intercept is the point at which the graph crosses the x-axis, and the y-intercept is where it crosses the y-axis. X-intercept is where it crosses the x-axis. Now let's take a look at a couple of examples real quick. We're going to determine the x and y-intercepts here. For this first graph, here's my y-axis, and it's crossing at 4 here, at a positive 4. So my y-intercept is, and I'll put a colon there, my y-intercept is, and it's a point. And it's the point 0, 4. And here my x-intercept, again being a point, I'm going to put it as a point, coordinate pair, xy coordinate pair. It's at 1, 2. So it's at the point 2, 0. Well, that's not too bad. So let's find the x and y intercepts of this one. Y-intercept is where it crosses the y-axis, and it's crossing at 3. So my y-intercept is the point 0, 3. And my x-intercept is the point, see, negative, that's it, all the way out there at negative 9. Negative 9, 0. Okay, a lot of these problems are yes/no problems, so I'm going to assign the homework from this section. It's on page 71, and I want to do 1 through 39 odd. A lot of these are yes or no, so it's not going to be too terrible, okay? And I hope everybody here has an opportunity to give Mr. Crowley a high five. They are spectacular. So cash yourself in a high five with Mr. Crowley when you see him.